Everyone, my name is Marissa and this is my video demo 0 to show how this microprocessor works. In this demonstration we are going to be subtracting 3 from 8, so performing a subtracting operation and storing for long term. So first we need to get the numbers 8 and 3 into our ROM, which is our read-only memory. So we're going to put 8 into ROM 0, which has the code of 1000, and then we're going to put 3 into ROM 1, which is 0011. Those are what gets us those numbers. Okay, now we need to make sure that we are going to store this properly. So we have to store it up in here. We need to go through here. So right now nothing is being ran through the bus. So let's get it where we can read. So right now it's reading 0, which is 1000, as we can see all the way through. We do not want that number first. That is our A number. We want our B number first. Our B number is going to be in ROM 1, which is 8, so we need to connect to that one, which is 001. We can change the different ROMs here, which one we want. So that comes here. You can see that it follows all the way through, and now we're reading that all the way across. So we want it to be stored while we get the next number. So right now it's going all the way to the AUL already. So first we're going to change this switch. Now we have it here. We're going to enable this. Right now it's reading 0. And so we're going to basically hit enter or clock it. So that way now it's stored here. And we don't want anything else stored there overriding it. So we turn that off. And we need our next number now. So we're still reading, but we want ROM 0. So we're going to do ROM 0 by changing the address. And now we can see that the bus now has this code in it. And we don't want it to go to store over that one, so we need to flip this switch, and now it's going directly to the ALU. And we can see there's a number over here, which is basically the calculation that's coming from the ALU. The ALU has different selections of what it can do. So right here, as these change, this number, you can see this number changed as well. And we want to have subtracting. So we want a subtracting mode, and subtracting is 0. And because it has A minus B, this is why it's important to have your numbers stored properly where you want them so it performs this operation correctly. So let's get to 0. Now this is here. That's what it calculated. And we need to store it. So the accumulator is set to 0. We need to enable that so that way it can store our calculation. Alright, as we see, this number changed and it is now 5. And we don't want anything overriding that, so we turn that off. And now it's sitting over here. Now we can put it to our output, into our bus, right? So we turn this on and we have this big red line across everything. And this is because it's trying to read the output and read the input. So we need to turn off the read operator. So now it's reading our output all the way across. This gives us the ability to write it into our data, into our RAM. So we need to turn on our write, but we also need to put it in the right spot. So our address needs to be put all the way down, and we're going to do it in RAM 6. So right now it's reading 0, and RAM 6 is 110. So you can see this one highlighted. All the way down, both writing and address is properly lit up to it, and now we can clock it. So we're going to clock it, and you can see right here that 5 is now stored in our RAM, and that will be our storage. So there's a couple questions that need to be answered. What is a bit? A bit is a binary digit. When working with a processor, it needs to be all the same. So if we click on this, our register, it has a data bit of 4 right here. So that one has 4, this one has 4, this one has 4, and actually our read-only memory have 4 bits as well. Say if we change this to 5 or 3, it'd be incompatible and it lights up all orange like that. So we need to keep all of it the same throughout the whole processor. And then another thing is our registers. We have 5 in total. There's 1, 2, 3, 4, 5. Registers store memory, more of a long-term memory versus short-term. Short-term is our ROM memory, and our random access memory, our RAMs, are more long-term, and they have registers to be able to store that and access them through the bus and calculate other things that way. The type of registers that these are parallel, I believe. They are parallel input and output because they read these simultaneously and they don't push the number through. So I believe they're parallel input and output. I hope you guys have a great day.